Oh yeah, this is an interesting and exciting one. How do you do certifications for a highly modular product? And so the key is actually a lot of these modules we have to certify individually. So I can actually open this up, laptop. We have, of course, like high resolution images of this online, but you can see that, of course, the battery has its own set of certs. The main board, actually, we do FCC and CE certs on this. And then some of the modules, like the expansion cards, for example, that you can plug in and swap out those ports. All of these are actually independently certified devices. And so you can, of course, use these not even with Framework Laptop. You can also use them with other stuff. We've actually seen some third-party products start to use them, which is pretty exciting. But then not everything. Like some of these modules are actually just certified within the laptop itself with the expectation that they're not really going to be used in any other scenario.
Legit. And you've got a bunch of them listed on the website here. Basically, if you go to the product pages and scroll down, you will find these different modules: Ethernet, micro SD, extra storage, USB-C, which is funny because it's almost like, is that just a pass-through
It
of,
is just pass-through. Yeah, it's purely passive.
Great. And HDMI, stuff like that, all kinds of different bays. And do you have different numbers of expansion ports depending on the size of laptop that you get?
Yeah, so the Framework Laptop 13, which is what we've been shipping for the last couple of years now, that has 4 expansion card bays, 2 on each side. Then the Framework Laptop 16, which is a product that we just announced earlier this year that we're shipping later this year, this has 6. It's got 3 on each side.
A couple of extra things that I would love to highlight: these amazing swappable bezels. How easy do you think it is for someone to create their own bezels that would be compatible with this? Say they have like a 3D printer at home. I
Yeah, this
realize.
is a tricky one, just from a thickness perspective, and also some of
Mm.
the complexity around the privacy switches at the top. It is something that's
Ah.
actually pretty difficult to fabricate this thing. I'll take this off. You can see the back side of it, but there's some actually very detailed mechanical structure on the back. So ribs, magnets, or rather steel plates to match the magnets that are on the A cover side, and then a lot of detailed mechanical structure to make those privacy switches work. So this one,
What?
unfortunately, even though it's like a pretty low cost, simple object, the tooling is actually quite substantial to be able to make something like this. Like this is not an easy piece to be able to injection mold. A lot of the other stuff like expansion cards, this is like very, very easy to go and design your own in 3D print. We've seen like literally dozens of different designs that people have in progress. And obviously, because they're so tiny, it's super cheap to get get them 3D printed if you don't have a home 3D printer. So this is like using a HP MJF process, and it's I think it was like if you get like 10 of these, they're like a few bucks a piece for the enclosure if you don't have a home 3D printer.
Wow.
We'll show generic. Let
Okay,
me
cool.
just open another
It's
project.
crazy. It's crazy cool.
Okay.
It's super, super cool.
So I was saying the flow in Eagle was create all your parts and then make your schematic. That really slows me down because when I have an idea of what I want to accomplish, I want to go and accomplish it. I don't want to go and make a bunch of parts.
Hmm.
And so you have some options where you can pull in SparkFun library, Eagle library, whatever,
Mm.
Adafruit library in order to start from those parts. But what I really like in Flux is that it follows the way that I want to design, and that's sort of where generic parts comes in. Often, if I'm designing a circuit like an instrumentation amplifier, for instance, I want to put some resistors in, but I don't know exactly what value I want. And so it's silly for me to go in and make a very specific part with an NPN and a package code and all of this stuff because I'm just going to change it later, and that's wasted effort. And so what we've done here is given you the option to change all of the features of this part. And so, maybe I have this in here and I have a generic capacitor and I want a particular cutoff frequency. And so I'm just going to guess that maybe I want 10 microfarad here. And then, maybe we'll do whatever, 100 ohms here. So I think you have the option to do some of that in other tools. What is really special is that in this version of generic parts that was user created, you can go in and change the package size. So say you're routing this and you're like, hey, I realize that I'm going to use a bunch more current here. My traces are very wide going to it. Actually, I need it to be like half a watt instead of an eighth of a watt. I'm just going to bump this up. And then I think that I want a 1206, so I'm just going to make it a 1206. And then I can go in and add manufacturer part number at the end instead of doing that at the beginning. And I just really like how this matches the flow on how I want to design a lot closer. I don't want to specify all this stuff up front. I just want to get it done, and then I'll add the specificity when I want.
Nice. This is nice.
And so this is enabled with user code that's inside of this part. So this part actually has a ton of footprints hanging out inside it. And then the user code is listening for the property. It's generating a list of properties. And then when you select the property, the user code is saying, okay, we'll swap out the asset dynamically for you.
Of course, Arduino is open source and will be forever open source hardware. This means that anyone can download the files from the website and put them in a production line and basically get instantly clones of the Arduino design. And this is by design. I mean, we truly believe in sharing knowledge, inspiration, also to foster innovation. Especially, we like this process, especially when it starts a circular innovation thing where people create remixes, add more ideas on top of what we shared initially. Of course, there are many cases where companies around the world, they take the files, they put them in production, and then they sell a clone, basically a copy of the original product. And this is totally fine because we are also supporting and creating an economy. So there is nothing wrong in this. We don't see that as a competition. Even though we are a company, we need to pay salaries at the end of the month. So of course we need to take care of that aspect. But that's not a problem. That's not a problem except when those boards claim to be made by Arduino. We call them counterfeits. Actually, they are legally called counterfeits, which means when they put the Arduino trademark, when they write manufactured in Italy. So when they pretend to be original products, this is not good. This is illegal, and this is damaging basically not just Arduino but the entire ecosystem. People, of course, are free to choose what they want to buy. It's worth mentioning that in the cost of an original Arduino board, there are many hidden costs that, of course, you will not find in a clone, even a legal clone, which is, of course, cheaper, but we are taking care of many aspects. For instance, one thing is that we manufacture this in Europe, entirely in Europe. We are proud of that, and which means respecting labor rights, everything that, especially in the Far East, is not always respected. So this is a cost that we are happy to pay. We have a lot of certifications about hazardous substances, radio compliance, conflict minerals. So the source of our supply chain is certified. So we make sure we don't buy components which come from areas of the world where it can basically fund wars or other bad things. There is the cost of R&D, of course, or the development that went into this product. We cover it with the sales of the original boards, but of course, a clone will just download the file and will not need to cover the cost of the development. Then we also do the development on the software side. So the Arduino IDE and the Arduino CLI, so the command line tool, and everything else, which is open source, they work with any board, not just Arduino. They work with all the boards made by any company in our sector for free. This is a cost that is on the shoulders of Arduino as a company. So buying an original Arduino also means that we can pay the salaries of the team that is working full time on the IDE and all the open source tools. But anyway, I'm not saying that there is a good choice or a wrong choice. Anyone is free to buy wisely, except for counterfeits. Yeah, of course. This is why we are a community.
I recently upgraded to like a Prusa Mini, and that printer is just insane. It just keeps going, and there is no servicing that you need to do for it. And yeah, it's an awesome printer, and it's what's enabled me to build things like TARS.
What types of filament do you usually use? Does it depend on the application for like heat and durability, or do you have a favorite that you stick with?
The things that I build are not exactly extreme in terms of having to endure temperatures or extreme pressure or like extreme mechanical situations. So I generally stick with PETG because it's a pretty good balance between like ABS like strength and durability and PLA like ease of printing pretty much. But for smaller applications like for the arms on TARS, I wanted to kind of try to preserve that flush box-like quality of the original TARS. So trying to figure out how to make flush joints was one of the bigger challenges that I had with version 3. What I ended up settling on was actually using TPU filament to create a kind of a flex joint. So when the arm pops out, you can see the main kind of axis of rotation is a flexible TPU printed joint. And the same goes for the joints on the fingers as well.
You have been working on this better Doc tentacle.
So basically, yeah, it's 3 Stuart platforms stacked on top of each other, and a Stuart platform has 6 degrees of freedom, so it goes up and down, it can move around, and it can roll and pan and yaw. So yeah, so it's just 3 of those, but it was actually a really interesting result to see 3 of them using both the translation and rotation axis to move around, and standing here it goes out shot basically. So the plan was to build a 6-stage one, but obviously the bottom stage is going to have that whole load of the whole thing leaning over on it. So the plan will probably be to use sort of brushless motors and ball screws on maybe the first 2 stages, then like a couple of stages of lead screws and motors, and then maybe servos like that one on the top 2 stages, and get the thing to be 6 to 8 feet and anchored to a big steel frame. And then it could be an interactive exhibit for events where people can, use like a 6-axis joystick or 6-axis controller, like I use for the robot dogs, where the joysticks rotate as well to give you 6 axis, and they could sit there and drive the thing around with a controller. But yeah, there's lots of big projects like that I'd like to do.
Are there new advances that you see coming out that will enable some of these projects, or like stuff that's being built in space, for example, so you don't have the constraints of gravity and stuff like that? I don't know.
Yeah, like all these things will work better in space because they'd know they would just float there, and you could use any tiny motors, and it'd probably all be fine. But no, I mean, so I think brushless motors there's some brushless motors now. So all of these are brushless drone motors, the sort of pancake motors, and then they've got an encoder on the back, and then in the middle of OpenDog is the O drives which control them. So there are now geared brushless motors that have the controller built in, so you just feed CAN bus data and power to it instead of having all of this stuff. There is in fact an O drive now that would have fitted on the back where that encoder is as well, if you want to homebrew one. And there are some brushless motors now that it's a brushless motor with a Hall effect sensor and the controller built into it, like tiny little things for little droids and things like that. So yeah, I mean, before it just means having big external controllers. Things are getting a lot more compact in that sense. But I'm not aware of any sort of space stuff, I think, that would help me that much.